Well, good evening, doctor, and good evening, colleagues. Well, the data that I'm going to be analyzing using the Tulip app is the distances between different cities and their correlation. The data that I chose to use is the data set is in regards to the location of the cities and their corresponding connection. So the node data ideally corresponds to the cities and their location, and the edge data defines the connection between these cities with their distances aligned. Just as you see in the Excel sheets that I will be uploading. So this is my node CSV that I'll be uploading onto the Tulip app, and this is my edges data that has relationship as sources and target. You realize that these sources are the IDs in the nodes data, and here we are trying to analyze the edges in the edges file. The source and target are the IDs and the distances there between these two cities or these different cities. And the distance is calibrated in kilometers, considering the data set that I'm using. So the essence of analyzing data using Tulip for this specific data set is majorly to utilize this data for transportation planning, whereby you identify the different hubs and routes for optimizing transportation networks, disaster responses. You analyze the connectivity to plan efficiency and response route, whereby the nearest or the shortest route possible you would be the best disaster response route, considering the different schematics that come through when you say in a war or when a disaster has happened, you would want to respond rapidly. Uh, Tourism is another way we can utilize this data, whereby you can identify the cities and the destination that are clustered in a given area, and you plan the travel routes properly. You can as well use these aeroplanes can use these routes to plan the nearest route in terms of kilometers between different cities and locations. Also, the supply chain optimization can simulate and optimize the supply chain between routes, between different cities by considering the distance between the routes as well. The other aim is as well ranking cities by utilizing centrality and distance, identifying the important hubs and cities. You will realize that I used the scatter map to plot where high densities are, and I'm going to share shortly. Then, as well, to visualize the actual locations of these cities. I'll go direct to the Tulip app, and you realize that I already ingested the data. But if you want to ingest this data, you go to import, then you choose the node data where you want to go and choose now the data which you've chosen. In this case, I won't ingest because I already ingested the data. Then as well, if you want to ingest the edge data, you will do the same. It is the same process. You will do the same, and this data will be ingested into the Tulip app, and this is the data. So you choose how to render this data. Distance will be in kilometers, and it is a number, which is an integer, and the target as well is a number, and the source is as well is a number. So I won't ingest this data because I already ingested it. But yeah, that is how it will be. The visualization that comes out will look like this, and you realize that you can easily now visualize this location vis-a-vis this location. You get. So you realize that Los Angeles is near this other location, San Francisco. And if you want to travel, say from Los Angeles, there is no way you would use a route, say at location node 5, which is Paris, 72, sorry, which is Paris, to go to San Francisco. You realize that it is much easier to travel from here to here than to travel from here to node 72, which is France, to San Francisco. So if you want to get the nearest route between these cities, you can clearly know that the distance between here, if factors remain constant, is between node 1 and node 3. So this is the shortest distance. As well, if you compare, say, distance of Auckland, which is this node here, it is too scattered. So you will definitely understand that a distance from here in Peru to Auckland, it's rather better you travel from, if you're planning your trip, say to Auckland, and you have a trip in Africa first, you can easily first land at this before you shift to go to Auckland. So this is how this data was represented on the graph. And yeah, you will realize that this tool uses the OpenStreetMap to map its data, its geographical spatial data. So this is the data that I ingested. And once you've ingested this data, it has distances, cities, and as well as the latitude and longitudes. And once you map it, this is what it will bring you. It will plot and try to show you the different notations. And once you done with that, you can now plot it on this map. So that is that relationship. You will also realize that the distance between these cities also differs in terms of when you compare, when you compare, say, a distance of Auckland and Los Angeles is far, and this is represented here in terms of by distance. You will realize that one that is up here by ID, Wellington, is very far from Los Angeles and San Diego and Ottawa, and this is visible by on this map. If you to see, like I had earlier mentioned, this here is Los Angeles. This one is Los Angeles, and it's, when you compare this distance to, say, distance this, which is 34, and this is Auckland, you will realize that it is too far from the other location. And this is well stipulated on this graph, whereby you notice that as the distance goes on going up, also the cities. So these cities are nearer each other compared to these that are up here. And this is well represented on this graph. Well, you can also plot data. These are some of the histographs that I've plotted. I will take interest in this one specifically, whereby I've plotted the longitudes and latitudes of the different cities. You realize that this dot represents Budapest, and this represents Prague. And by latitude and longitude, you realize that the concentration of these cities is literally in the same location. So if you want to plan for, say, a trip, you plan for these cities for cost benefits, you plan for these cities that are concentrated in this location that is slightly in the same location. That is the relationship, and you will realize that also by ID, Auckland is here, and by latitude is it's located at this location, and these some of these also concentrate or are along the equator and I mean are along the longitude, literally share a longitude near each other, and they correlate. So you could easily know the cities that are near each other in terms of longitude and altitude. And like I earlier mentioned, this will help you to conclude in terms of ranking the city by centrality or distance, identifying the most important cities in the hub, visualizing the clusters and communities that are near each other, then also to when you planning, like e-governments planning for transportation, you would know the nearest route to, say, Damascus or to Budapest. If you want to plan for Uganda Airways, say for example, wants to plan for its airplanes or for its route to London, it would know which countries its planes will settle and have a stopover. Then also disaster response, whereby say a war and you don't want to pass in country X, you could easily find the nearest route. Tourism as well, and supply chain optimization. Thank you for the time, and that is the end of my presentation. I thank you.